Hi everyone, today we will solve this amazing math Olympiad problem, and it is from Azerbaijani National Junior Math Olympiad 2026. It says we are given this set numbers from 1 to 30 and we just select the composite numbers and we write them in the whiteboard. Then we delete 3 of them, the composite numbers, and we are asked that if it is possible to group the remaining composite numbers in 3 groups, that in each group the product of the numbers is same. In this question we will use the Legendre's formula. I explained that in one of my another video. Okay, so we have these prime numbers 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. To calculate, we know that there is 129 in 30 factorial, 123, 119, 117, 2, 13, and 2, 11, 4, 7. For 5 we have 6, 5. No, actually 7, because we have 25. It has 2 5s. Yes, that is why. sorry. And for 3, let's calculate. 30 divided by 3 plus 30 divided by 9 plus 30 divided by 27. 1 here, 3 here, and 10 here. 14. For 2, let's calculate. 2, 4, 8, and 16. It is a maximum power of 2 that fits in 30 factorial. 30. Okay, so we have 15 here, 7, 3, and 1. Overall we get 26. However, in the question we are given that we delete all we write all composite numbers. However, for instance 3 or 11, these numbers are not composite, they are prime. Also 1 is not composite. That is why we exclude that numbers. It means that we just subtract 1 each of these powers. So in the end we are left with this: 2 to the power 25, 3 to the power 13, 5 to the power 6, 7 to the power 3, 11, 13, and the remaining ones will be 1, because we will get, for instance, 9 to the power 0, and it is 1. We don't need this part from here to here. Okay, and we are wanted that to divide these numbers into 3 groups, and each group has the same product. It means that overall we need to find a cubic number. When we divide the numbers, in the end each product will be same, so the overall product will be a cube of some natural number, or we can say positive integers cube. Okay, we can see that 7's power is 3 and 5's power is 6, and they are divisible by 3, so it is okay. We can divide these into 3 groups. However, there is a problem for 2, 3, 11, and 13. So we need to delete 11, 13, 1, 2, and 1, 3. However, in this case we need to raise 3 composite numbers, but when we try to create 3 composite numbers with these prime numbers, we can't do it. At least we will get 1 prime number, and it's not possible because we need to delete composite numbers. That is why we try to multiply these numbers with some other prime numbers, but we try to make it as small as possible. So that is why we just we just multiply by 8. So we will do it like this. It means actually we will subtract 4 instead of 1 here. So we will get 26, 22 and 12. And as you can see, these three are composite numbers, so everything is okay for now. And then we need to show that there is indeed 3 different groups containing different numbers, composite numbers, that the product of them is same. So you can think it by yourself, and I did it. For instance, let's say there are 3 groups, A, B, C groups. In A group we have 8, 14, 24, 25 and 27. In the B group we have 6, 18, 20, 28 and 30. And in the last group 4, 9, 10, 15, 16 and 21. You can multiply these numbers by yourself, and I also did it. In the end, in all of these 3 groups we will get the same number, 1,814,400. So we proved that yes, there are in these 3 numbers composite numbers that we can erase, and with the remaining numbers, composite numbers, we can create 3 groups that the product in each group is same. Thanks for watching, and don't forget, get math be best.